Good day, everyone. Welcome to another wonderful class on evaluation physics. Mr. Duro is my name, your regular host and instructor on evaluation physics. In today's class, the emphasis is on lens formula, which is a major subtopic under refraction of light in lenses. So sit back while I run you through the various formula that is obtainable in this subtopic and also what is involved and those key notes that must be noted when applying the formula to solve question. Number one formula is magnification. Now, magnification is a ratio which expresses the size of an image with respect to an object. It could be greater than 1 or less than 1, but it can never be equals to 1. The only optical instrument that gives us the magnification of 1 is a plane mirror. So, in a lens, it is either the magnification is less than 1 or the magnification is greater than 1. And the formula for calculating magnification is image height divided by the object height. Similarly, based on experiments, it was discovered that image height and image distance, they have a direct proportion. That is, image height and image distance varies in direct proportion to one another. So instead of quoting image height and object height, we can as well express the formula for magnification M to be equals to image distance divided by the object distance. Now, each of these two formulas can actually be used interchangeably when you're solving questions on magnification. Don't forget, magnification is the ratio of the image height with respect to the object height. It has no unit. It is a unitary quantity. So each of these formulas can actually be used interchangeably in calculating magnification. The formula we use for image distance in physics is V, while that of object distance is U. Now, secondly, 1 over U plus 1 over V is equals to 1 over F. This is the second formula that is obtainable in the lens. Earlier on, I've told you what U and V represent. What about F? What does F stand for? F stands for focal length. And that is the focal length of the lens. Now, while using this formula, it is important to lay emphasis on these two items: image distance V and focal length F. In our previous class, I've expressed to you the various types of lenses that we have. But for the purpose of this lens formula, we are going to focus on just two: the biconvex lens and the biconcave lens. Biconvex lens, which is also known as the convergent lens, and the biconcave lens, which is also known as the concave lens. Now, what do I mean by paying attention to these two? Object distance at every point in time is positive. Irrespective of the distance from the lens, it is always positive. But image, it has some key notes you must note. Number one, if the image is a virtual image, then your V must be negative. Either you are looking for it must be negative. If it is given in the question, you must put minus beside the V. For instance, the image distance of a virtual image from 20 centimeters from the lens will be expressed as V is equals to minus 20 centimeters. Very important. Also, F. If it is a converging lens, then the focal length must be positive. You don't need to put that because every value written without any symbol beside it is positive. So you can leave it as that. But if it is a diverging lens, then it must appear as negative. Please, this must be noted when these functions are given in the question. When you are substituting to this formula, if focal length is given and it is a concave lens, which is otherwise known as diverging lens, a minus must be placed beside it. If it's a convex lens, no problem. The image, if the image distance is given and it's a virtual image, you must put a minus beside it. If it's a real image, no problem. Just leave it the way it is. Another instance is where they might not tell you that the image is virtual, but in the case of converging lens, if the image is upright, in that wise, the final image is virtual. Because in a convex lens or a converging lens, the image is said to be virtual when the image is upright or stated in the question that it is virtual. So either of those cases connotes that minus must be placed beside the image distance if it is given in the expression. Don't forget I said that you place minus beside the quantity of focal length of image distance if the expression is given in the question, not when you are determining it. If you are determining it and your final answer is negative, it implies any of this. But if you are given in the question, that minus must be placed beside the formula so as to make it effective. It's very, very key you understand this. Also, going back to magnification, the magnification of a converging lens is greater than 1. And at times, it will also be what? Less than 1. And at times, it will also be equal to what? 1. It's unique. It has these various magnifications depending on the object position from the lens. But for a diverging lens, the magnification is at all times less than 1. Please note that. Then the final formula for this class is the power of a lens, which is 1 divided by focal length. The power of a lens is not measured in watts, just like you do for mechanical power and electrical power, but rather it is measured in a unit called diopters. D-I-O-P-T-R-E, diopters. When you're using this formula, ensure that your F, which is the focal length of the lens, is expressed in meters. If it is given in centimeters, you convert it to meters by dividing it by what? 100. Thank you for listening. My name is Mr. Duro, your regular host and uncle on evaluation physics. I hope to give you my next class a very simple work example that applies these formulas in order to get the answer to the question. Thank you for listening one more time. Just in case, hit me up on my WhatsApp number 08060438946 and be sure you obtain a first class information and tutorial lectures on whatever topic you put across. Many thanks.